All right, welcome to 9.3 optional video. Thanks for joining for these examples. Sorry if they go a little bit long. Graphing always takes a little bit longer. So find the center, vertices, focal points, and asymptotes of the following hyperbola and sketch a graph. So first, if I'm going to talk about the center of this hyperbola is 0, 0, and I know that because there's nothing being subtracted from the x squared and y squared, and it's currently in standard form. Okay, great. So I'm just going to go through the plotting of this while I do everything. 0, 0, this center. I know that because this is an x squared hyperbola, meaning that's the term that comes first and is positive, this must open to the left and right. Again, my transverse axis is horizontal because it's along x. Here I have my a squared and my b squared, which means a is equal to 12, b is equal to 4. To solve for c squared, I do a squared plus b squared. So c squared is equal to square root 160. Sorry about that. C squared is equal to 160. So c is equal to square root 160, which is 4 square root 10. So if I'm going to talk about my vertices, so that I can get all this sketch done, my vertices have to be going along the transverse. So I know they're moving left and right. And it's going left and right a units in this case. So I'm going left and right 12. So I'm going to have negative 12 comma 0 and 12 comma 0 plus or minus 12, 0. Next, I have my focal points. My focal points is when I go left and right C units. Let's just label this as vertices, vertice, center. I go left and right C units, again from the center. Now, you may not know exactly what 4 square root 10 is, but you know that square root 10, because square root 9 is 3, this is a little bit more than 3 times 4, which gives me 4 times a little bit more than 3. So that's going to be a little bit more than 12. And how is that helpful? Well, because what you know then is my focal point is pretty dang close to this vertex because it's just a little bit more than 12. So here's my focal point, which is a 4 square root 2 comma 10. And here's my other focal point, a negative 4 square root, 10 comma 0. I didn't read that right at all. I think I said a 2. So my focal points are at plus or minus 4 square root 10 comma 0. Now, you do not just draw any hyperbola going through here because we do have some specifics that we know about this hyperbola, and that comes from the asymptotes. So first, if we're just going to list the asymptotes, okay, that's not how you spell it, asymptotes, we're going to be using the equation. For a horizontal transverse, it's y equals k, which is 0, so plus or minus, b over a, so 4 over 12, which is 1/3, and then x minus h, which is just x. So my asymptotes are y equals plus or minus 1/3 x, but you are not going to necessarily graph those by using the linear function. You're not going to be like, okay, so I have to go up 1 over 3, starting at whatever value. The way in which we graph this is we've already done A. We're going to do B. So we're going to go up 4 and down 4 because B goes in the opposite direction of A. And then what we do is we draw in dotted lines this box going around A and B. So that now, if I want my asymptotes, they have to be diagonals of this rectangle, and they have to go through the center of my circle. So that's how we're going to get or draw our asymptotes. And what do I need those asymptotes for? Well, now when you actually draw this hyperbola, what we're looking for is it to be bounded by those asymptotes. You know, if you draw something that doesn't have asymptotes, it's not bounded by those. It's just, you know, continuing on sort of like a parabola. We're going to have a little bit of an issue because these are bounded by those asymptotes. I can't say that enough. I could say it more. I won't, except for on the next problem. Okay, the next problem. Find the center, vertices, focal points, and asymptotes of the following hyperbola, and again, sketch the graph. So same instructions here. First thing I'm going to do is just draw us a nice little graph. There we go. That's what we're using. So because the y squared is the portion that comes first, I know that my transverse axis is vertical, so my hyperbola is opening up and down. My center is at h, which is -3, comma k, which is 2. So I'm going to go to -3, 2, and place my center. Next, I need my vertices. To get my vertices, I need to know what a is. Again, this is a squared, no matter what. In this case, it's underneath y. A squared and b squared for a hyperbola, though, they're not moving. The numerator's moving. So a equals 5, b equals 7. So I'm going to be moving, in this case, up 5 units, which is going to put me at -3, 7. And I'm going to be moving down 5 units, which is going to be putting me at -3, -3. Next, I need my focal points. My focal points require that I solve for c. So I know c squared is equal to a squared plus b squared. So c squared equals 64. So c equals 8. Did I add that right? No. C squared equals 74. That was almost too easy. So c equals square root 74. Square root 74 doesn't simplify, but if I'm going to talk about what square root 74 is, I know that square root of 64 is 8, and square root of 81, is 9. And this is somewhere in between there. So this is just a little bit more than 8, which is fine because a was 5, so I just know my focal point somewhere up here. And we'll call that -3, 2 plus square root 74. A little bit down here, and we'll call that -3, 2 minus square root 74. So for my focal points, you can just write it as -3, 2 plus or minus root 74. Here, I didn't write it as 2 plus or minus 5 because I could actually do 2 plus 5, 2 minus 5, and get an integer. Next, all we have left is our asymptotes before sketching this. If I'm talking about my asymptotes, it's in the form of y equals k. K here is 2, plus or minus. And then because this has a vertical transverse, we're going to have a over b. So 5/7. And then x minus h, so x plus 3. Again, in terms of your graphing of those asymptotes, you know, that I don't know, what's 5/7 of 3? I don't want to think and then add 2 or subtract it from 2. No, what we're going to do is just move ourselves b units to the left and right. So I'm going to move 7 to the right, which would put me right about here, and 7 to the left, which would put me right about here. Notice I didn't put in all those tick marks, but they are pretty accurate. And then I draw my asymptotes going through. Remember that they have to meet at the center and go through the center. So now if I'm drawing this hyperbola, it's bounded by those asymptotes and going through that vertex, just sort of touching that vertex. So you've got sort of this really wide hyperbola in this case. You know, arbitrarily might be off a little bit because of my sketching. I'm not a very good artist. All right, find the standard form for the equation of the hyperbola with vertices at 2, 4. 8, 4, and focal points at 10, 4, 0, 4. So in this case, this is one of those where like I like to give myself a little sketch, 2, 4, and 8, 4, 3, 4, 5, 6, 7, 8, and then 10, 4, and 0, 4. So what I know right away is I have a horizontal transverse, which means this is in the form x minus h squared over a squared minus y minus k squared over b squared equals 1. B squared equals 1. Okay, that's a b. So my center needs to be the midpoint of the vertices or the midpoint of the focal points. It doesn't matter which one you think of. So the midpoint between 2 and 8 is going to be at 5, 4. So I know that my center is 5, 4, which gives me my h and my k. A represents the distance from that center to the vertex, or the other vertex, doesn't matter. So if I started at 5 and went to 8, then A is equal to 3. C is the distance from the center to the focal point. Ooh, gosh, I can't do that going to the left. So talking about the center to either of those focal points, I moved a total of 5. And I know that a squared plus b squared equals c squared. So 16 plus b squared equals 25. So b squared equals 9. This also means a squared equals is a 3. Oh, goodness. La, la, la. I just switched those. I got a little bit ahead of myself. 9 and 16. So a squared equals 9. C squared is equal to 25. Now I have all the information that I need in order to just write the equation. X minus 5 squared, because that's what h is, over a squared, which is 9, minus y minus 4 squared, because that's what k is, over b squared is 16, equals 1. Please don't forget the equals 1. It is important to make sure that it's a hyperbola. All right, moving along. Put the following into standard form. So I only have x squared and y squared terms, which is nice because it doesn't mean I have to complete the square. I'm just going to divide everything by 6. 2 over 6 gives me 1/3, or x squared over 3. Minus 3 over 6 gives me 1/2, or y squared over 2. And 6 over 6 gives me 1. Similarly, if I have that but have an x and a y term, I'm going to have to complete the square. So the first thing I do is rearrange. And I'll move that -8 or that 18 to the other side. So now if I'm completing the square, remember that to complete the square, your lead term needs to be a positive 1. So I'm going to factor out this 9. I get x squared minus 4x. Half of -4 is -2 squared is 4. And 9 times 4 is 36. So I'm going to balance this with a 36. Over here is where people always make a mistake. You need to factor a -1 out, because right now it is not a positive 1 y squared. I know that the equation has a negative in it, and that's what you need to factor out, because that negative is really being distributed to everything. So I get y squared plus 6y, half of 6 is 3, squared is 9. And now this is a minus 9. So I get 9x plus 2 squared minus y plus 3 squared equals 9, and divide everything by 9. So x plus 2 squared minus y plus 3 squared over 9 equals 1. Doesn't matter that this doesn't have a denominator. It does. It's just 1. So I know a squared is equal to 1. All right, we're on our last slide. Find the standard form for the equation of the hyperbola with vertices at plus or minus 3. And focal points at plus or minus 6. So because of that, I know my center must be at 0, 0. It has a horizontal transverse, which means I'm starting with x minus h squared, and h is 0. So I'll have x squared minus y squared equals 1. And look, I've got like almost all of this already done, and I've done such minimal thinking and pretty much no work. Now all I need is a squared and b squared. Remember that what has to be here is a squared, and what has to be here is b squared. A is the distance from center to vertex, so a is equal to 3. C is the distance from center to focal point, so c is equal to 6. A squared plus b squared equals c squared. So I get 9 plus b squared equals 36, so b squared equals 27. Again, my b squared is underneath the second term, and my a squared is underneath the first term. All right, that's it for the examples. Get started on some of that book work. Jot down if there's any questions from the notes, from the examples, things that you need to bother us with.